Section 1.6 is about quadratic equations. Application time. It took Josh 30 minutes longer to drive 100 miles than it took Bree to drive 90 miles. If Josh averaged 5 miles per hour less than Bree, then what was the average speed of each driver? Okay, so we have Josh and we have Bree. Here's Josh, and he's traveling 100 miles. And here's Bree, and she's only traveling 90 miles. It took him 30 minutes longer than it took her. So if her time is t, then his will be t plus 30 minutes. But these are usually in hours, so 30 minutes would be half an hour. So t plus half an hour. It tells us that Josh averaged 5 miles per hour less than Bree. We don't know anything about Bree, but we know that Josh's rate was 5 miles per hour less than hers. We want to calculate the average speed of each driver. So there are several ways we could work this problem. I think we'll just go with this way. We can write those equations using distance equals rate times time. Let's set up Bree's equation because it looks like it may be a little bit easier. So Bree, her distance was 90 miles, and it's equal to rate times time. So since we're looking for the average speed of each driver, what we could do is just solve both of these so that there's r's in here and there are no more t's. So why don't we solve this for t so that we could substitute it in for the t up here. Let's see what that means. If we solve this for t, we divide both sides by r. We end up with t is equal to 90 over r. Well, if that's the case, I can replace this t with this 90 over r. So for Josh's equation, we would have distance equals rate times time. Well, his rate is r minus 5, and his time will be 90 over r plus 1/2. Now we just need to try to solve this for r. So multiply all of this out, we get 100 is equal to r times 90 over r is just 90. R times 1/2 is r over 2. Then we have negative 5 times 90 over r. That's negative 450 over r. And then negative 5 times 1/2 is negative 5/2. Now, as usual, I like to get rid of my fractions. So I think what I'll do at this point is just multiply everything by 2r. If we do that, 2r times 100 is 200r. 2r times 90 is 180r. 2r times r over 2, the 2's will cancel each other out. So you just have r squared. 2r times negative 450 over r, the r's cancel each other out. So you have negative 900. And then 2r times negative 5/2, the 2's cancel each other out, and you have r times negative 5. Phew! Okay, we need to try to put this in standard form. So what we want to do is combine these. So we have 200r is equal to r squared. 180 minus 5 is going to be 175r, and then minus 900. Then we're going to subtract 200r from both sides. So we end up with 0 equals r squared minus 25r minus 900. Now it is in standard form. Now we have a quadratic equation, and we can solve it using any of those 4 methods that we've learned. When you have really large numbers like this, it's usually a good idea just to use the quadratic formula. So let's see how that works. In this problem, A is 1, B is negative 25, and C is negative 900. So we have R is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So we get negative of a negative 25 plus or minus the square root of 25 squared is going to be 625. Then we have a negative 4 times a negative 900, and we get a positive 3600. When you add those two together, you get 4,225 all over 2. Now, since this is an application problem, we usually do want some sort of decimal answer. So let's go ahead and find the square root of 4,225. Oh, it's a perfect square. That's pretty cool. So we get 25 plus or minus 65 all over 2. Well, 25 plus 65 is 90 over 2. And 25 minus 65 is a negative 40 over 2. So we're going to end up with 45 and negative 20. So how can we have two different answers? What are we looking for? We are looking for the average speed of each driver. Go back to our answers. So what does this mean? We're looking for average speed. This can't be a speed because it's negative. So we want to know the average speed of each driver. Back at the original problem, we said that Josh's speed is whatever R is minus 5, and Bree's is actually whatever R is. So that means that Bree was traveling 45 miles per hour, and it means that Josh was traveling 45 minus 5. So he was traveling 40 miles per hour. Last question. A ball is tossed straight upward. Its height h in feet at any time t in seconds is given by this formula. For how long is the ball in the air? So when you throw a ball straight up, it goes straight up. Imagine that's a straight line. And then it turns around and it comes back down, right? This is the ground. So what is the height here and here? At this point, the height is actually 0. So the ball is in the air as soon as it leaves the ground and comes back to the ground. It's in the air all that time. So can I just set h equal to 0 and find out what t is? How long the ball is in the air? Let's see what happens. 0 equals negative 16t squared plus 40t plus 6. This is a quadratic equation. We can use the quadratic formula. It is in standard form. So not x, but t. T is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. $40 squared is 1600. 4 times 16 times 6, that would be 384, and it's positive, and that's all over a negative 32. $1,600 plus 384 gives you 1,984, and that's all over negative 32. So let's get a decimal for that. The square root of 1,984 is equal to approximately 44.5. What I'm going to do is store that number in X in my calculator. So let me make a little note. I stored this in X. That just means that's where I put it in my calculator. So I get negative 40 plus or minus whatever X is all over negative 32. So in my calculator I do negative 40 plus X, get a number, and then divide it by a negative 32. And I get approximately, let me make some approximates here, negative 0.14. Then I do negative 40 minus X, get a number, divided by negative 32, and I get approximately 2.64. So how do I know what my answer is? For how long is the ball in the air? Can it be in the air negative seconds? No. That means the ball is actually in the air for 2.64 seconds.